afternoon. Today's lecture topic is Artificial Intelligence in Electric Power System. Myself, I am Pradeepa. I had nearly 10 years of teaching and research experience. Now I am working as an assistant professor in PSNCET College of Engineering and Technology. Today let me see about what are the artificial intelligence techniques which is involved in the power system. So these are the outline of this today's lecture series. So first we see about what is AI, that is artificial intelligence. Next, introduction about the power system. Next, major developments and investments. Next, problems. What are the problems associated in the power sector, Indian power sector? So what is the need for this artificial intelligence in power system? And what are the conventional methods which are used in this power system? Next, what are the AI techniques which is involved in power system? Next, what are the latest AI techniques which is used in this power system network, and what are the challenges of artificial intelligence techniques in power system, and what are the future advancements of AI techniques in this power system. So these are the outline of this today's lecture series. So let's first see about what is artificial intelligence. We all know the artificial intelligence is commonly the AI, which is understood to be the intelligence exhibited by the machines and software, for instance robots and computer programs. The term usually wants to describe the project of developing these systems which is equipped with the intellectual processes such as features and characteristics of humans, just like the ability to think, reason and find the meaning and generalize, distinguish and learn from the past experience or rectify the mistakes. So the artificial general intelligence is intelligence of hypothetical machine of computer which may accomplish or any intellectual assignment successfully which a person's being can accomplish. So this is the artificial intelligence. Once again I repeat, artificial intelligence is understood to be the intelligence exhibited by the machines and software, for the instance robots and computer programs. So next is power system. Why we use this AI in the power system? So first we see about the power system. The normal electric power system is the network of electrical components which is used to supply, transmit and use the electrical power to the consumers. So the power system engineering is a subdivision of electrical engineering that deals with the generation, transmission, distribution and utilization of electrical power. And the electrical devices connected to this power system network is such as generators, motors and the transformers. Normally we can say the power system consists of the three stages. First is generation, second transmission and distribution. So this is the power system. So introduction, next is introduction about power scenario in Indian grid. So the power sector in India is mainly governed by the Ministry of Power. The three pillars in the power sector, such as I already told, that is three sectors in the power system is generation, transmission and distribution. And generation is divided into three sectors such as central sector, state sector and the private sector. Normally the power sector is the only key sector in the India's infrastructure growth. And this power sector is the essential for country's power sector to meet the planned capacity. Power sector in India is currently a developing stage, and it supports the growth of various sectors such as infrastructure, manufacturing, commercial enterprises and railways. According to the recent survey, India is the 6th largest in terms of power generation. So next we see about what are the major developments and investments involved in this Indian power sector. In March 2020, central government signed virtual agreement to conclude a sale in Kamarajar port, and it will receive the 13,500 crore for the power generation. And similarly, in December 2019, NTPC announced an investment of 50,000 crore to add 10,000 gigawatt solar energy capacity by 2022. In 2019, Adani Transmission planned to acquire the Bikari power transmissions. So, thus the artificial intelligence is very helpful to cut the energy waste, lower cost, and accelerate the use of clean renewable energy sources in the power grids in globally, and along with improving the operation, maintenance, control, planning, and execution of the power system. So next, what are the problems associated in the Indian power sector? The main problem is inadequate last mile connectivity. This inadequate last mile connectivity is the main problem which is used to supply the electricity to the consumers. And continuous urbanization and growth of population results in increasing the power consumption in buildings. And India is facing a very several shortage of fuels, and another main drawback is a problem associated in the Indian power sector is poor power line connectivity and also a shortage of natural gas. So thus we go that the continuous and reliable supply of electricity is needed for functioning of today's modern and advanced society. Since this early in mid-1980s, most of the effort in power system analysis has turned away from the methodology of formal mathematical modeling, which came from the areas of operational research, control theory, and numerical analysis techniques, which can be used with the help of artificial intelligence. The power system keeps on increasing on the basis of geographical regions, assets additions, and introduction of new technologies in the power system three pillars, that is generation, transmission, and distribution. Thus, these AI techniques have become most popular for solving the different problems in the power systems like control, planning, scheduling, and load forecasting, etc. So these techniques can deal with the difficult tasks faced by applications in modern large power systems with even more interconnection, which is installing to meet the increasingly load demand. Thus the application of AI technique has been very successful in many areas of power system engineering. So what is the need? Why we go for this artificial intelligence in power system? Normally the power system analysis has a conventional techniques to monitor the voltage, current, phase angle in generation and both transmission and distribution side network. But in the conventional techniques is more difficult, such as it is very complex, versatile, and large amount of information is used for calculating and diagnosing and learning. So this leads an increase in the computational time period, and also it affects the accuracy due to the enormous amount of data sets. That is extensive and vast system data handling. So the modern power system operates which is very close to the limits due to ever increasing energy consumption and extension of currently existing electrical transmission network and lines. So this situation requires a very less conservative power system operation and control, which is possible only by continuously checking the system states, which is much more detailed manner than it was necessary. And the sophisticated computer tools are now the primary tools which is solving the difficult problems that arise in the areas of power system planning, operation, diagnosis, and design. So among these computer tools, this artificial intelligence has grown predominantly in recent years and has been applied to the various areas of power system. So this is the need for the AI, because in conventional methods one main drawback is it is very complex for large size system, and if the system is a very large, means it takes a more computational time to execute the optimal solution. So and also in transmission and distribution side, we have continuously monitor the data frequently to execute the optimal solution. So thus we go for this AI in the power system network. So these are the conventional load flow methods in the power system. We all know that there are 3 conventional methods in the power system network. So power system studies. So 3 methods are, first is Gauss-Seidel, GS, we can call it as GS method. Second is Newton-Raphson, that is NR method. And third is fast decoupled load flow method. So these 3 methods. So first we see what is these 3 methods and what are the drawbacks in these 3 conventional methods. So first we see about a Gauss-Seidel method. In Gauss-Seidel method, it requires a large number of iterations to reach the convergence. Once the system, when the computation is convergence only, we can get the optimal solution. And the computational time per iteration is very less, and it has occurred only in a linear convergence characteristics. And the number of iterations required to convergence increases with the size of the system, and it has very less memory requirements. So these are the drawbacks in the first type of conventional load flow, that is this iteration is dependent of the size of the system. If the system size increases means then the number of iteration also increases, and it has very less memory requirement. So this Gauss-Seidel method is only applicable to the small size system. So next, this second method is Newton-Raphson. In Newton-Raphson, it requires a less number of iteration when compared to Gauss-Seidel, but it takes more computational time when compared to the GS method, and it has a quadratic convergence characteristics. Here when compared to GS, this number of iteration is independent to the size of the system, and it has more memory requirements. So in NR, we can summarize this NR is, it has very less number of iterations when compared to GS, but this computational time is very large when compared to the Gauss-Seidel method. So third is a fast decoupled load flow method. In fast decoupled load flow method, it requires more number of iterations when compared to GS and NR, and when compared to computational time, this computation time is very less when compared to the other 2 methods, and this iteration also, it depends on the size of the system, and it also very less memory requirement when compared to NR method. So to summarize this FTLF, this has very less memory requirement, and also the iterations depends on the size of the system. So as I already said, this Gauss-Seidel also, the iteration is depend on the size of the system. So if the system size is very less means then the iteration is very less, number of iteration will be very less. If it is a large number of system means then it takes more number of iteration. If the iteration increases means then also the computation time also increases. So these are the main drawbacks involved in the load flow technique, conventional load flow methods. So that's why we go for this artificial intelligence techniques. Artificial intelligence technique means it is very simple and quick and have very good accuracy to give the optimal solution. So next we see about what are the major families of this artificial intelligence techniques. This main major 4 categories is, first is artificial neural network, that is ANN. And second is agentic algorithm, that is GA, and third is expert system, and we call it as XPS, and fourth is fuzzy system. Let's see one by one what are the artificial intelligence techniques. We can see what are the methods used in this each category, and what are the advantages and also the disadvantages in the AI techniques. So first we see about the artificial neural network, ANN. Normally this ANN or biologically inspired system which can convert a group of inputs into a group of output by network of neurons, which each neurons produces one output as a function of inputs. as a fundamental neuron is often considered as a processor which makes an easy non-linear operation of inputs producing a single output. So this can be classified by the architecture, which can be as 3. That is a number of layers and topology. That is number of layers and topology consists of connectivity pattern and feed forward and recurrent pattern. Next, second is inner layer. Inner layer means we can give us input units. That is, nodes are the input units which does not process the information and knowledge, but it distributes this data and knowledge to the other units. Next, the third is hidden layers. Hidden layers means the nodes are the hidden units that are not directly evident and visual, but they can supply the network power to the other units, that is to map or classify the non-linear units. Next, final is output layer. This is the nodes are the output units which encode possible values which is to be allocated to the case that is a given data set which is under considerations. So what are the advantages in this artificial neural network is, first is the speed of processing. It is a very good speed when compared to the other methods. Next, second is it does not need any appropriate knowledge of the system model. And third is they depends on the fault tolerant. And this artificial intelligence is very fast and robust, and it possesses brains which is adapt to the given data informations. And they need the potential to generalize the data, and also they need the power to handle the situation which is incomplete data and knowledge and corrupt the data. So these are the main advantages which is used in the artificial neural network technique. And also it has some disadvantages, demerits. That is, it is very large dimensionally network, and results are always generated even though the input file is unreasonable, and it is not scalable. That is, once the artificial neural network is trained, which is to do a certain task, and it is difficult to increase the other task without retaining the neural network. So as I summarize this artificial neural network, that is I already said this is a biologically inspired system which can convert a group of input to the output, and it is very fast and robust when compared to other methods, and it depends on the fault tolerant. And the main drawback is it is a large dimensional network, and the results are always generated even though if the input file is unreasonable. So this is the artificial neural network, and where we can use this artificial neural network in power system means we can use this artificial neural network in power system stabilizers and load forecasting and fault. Third is a fault diagnosis, particularly in the substations, and fourth is a security assessment, and fifth is state estimations of power system, and sixth is contingency screening and voltage stability assessment. Also for voltage profile also are included, and protection and relay purpose and load modeling. So we can use this artificial neural network in this above sectors. Second is fuzzy logic. In fuzzy logic means fussification, processing and defussification. Fuzzy logic means here the criteria signals are fussified in order to account for dynamic errors of measuring the algorithms. The fuzzy signals are compared with the fuzzy sets. First we have defined the fuzzy rules. Based on the fuzzy rules only we can get the output of defussification data. Here the several relaying criteria are used in parallel. The criteria are aggregated by means of formal multi-criterion decision-making algorithms. Here the tripping decision is mainly depends on multi-criteria evaluation of the status of protected element. So I already said that this is the block diagram of fuzzy logic. Here we can fussification with the help of a fuzzy set or fuzzy rule. The data are fussified, and we can get next second step is decision making based on the knowledge based rule. The decision making is processed, and third step is a defussification. Finally, we can get the optimal solution. And where we can use this fuzzy technique in power system means we can use this fuzzy in stability assessment and enhancement process. Stability assessment and enhancement means whether it can be a voltage stability or a transient stability, anything we can use this fuzzy AA technique for stability assessment and enhancement purpose. And second is a power system control. The power system control we can use this fuzzy technique. And third, fault diagnosis, and fourth, security assessment, and load forecasting in the power system, and reactive power planning and control, and state estimation of the power systems. So these are the major applications of fuzzy AA techniques. Thus again summarize this fuzzy AA techniques, that is, it is a centralized signals which is fussified, and in order to account the dynamic errors of the measuring algorithms, there is 3 stages: fussification, decision making based on fuzzy set knowledge rule, and third is defussification. And applications, major applications are state enhancement and assessment, and load forecasting and state estimation process. And the third technique is expert system. So the first expert system included is a few heuristic rules based on experts' experience, and it needs a knowledge base to work the given data sets. Once the generic inference engine uses the facts, and it reduces to detect the new facts, which allows the firing of other rules, and this process continues until the base of the fact is saturated and the conclusion has been reached. So this is the block diagram of the expert system. In inference engine there is 2 inputs, that is a data sets and a knowledge base. This next the inference engine is processed. After then finally we get the optimal solution of the given power system network. So where we can apply this expert system in power sectors, in power system is all the application can solve the offline tasks such as system coordination, post-fault analysis and fault diagnosis. Yet there is no application is reported in this expert system technique, which is employed as a decision making tool in online operating protective regime. So these are the major, previously we have seen that these are the major techniques involved in this power system, that is first is artificial neural network, and second is fuzzy, and third is expert systems. So there are some other AI techniques which is used in distribution side also. That is what the load flow methods is, Newton downhill, second is current injection method, third is hybrid superposition or Gauss-Seidel method, fourth is improved hybrid superposition and Gauss-Seidel method. Next, branch current power or feed forward or feed backward network method. Next, genetic algorithm based load flow method. Next, PSO, particle swarm optimization based load flow method. And finally, the artificial neural network based load flow method. Each method has same advantages and disadvantages. Let's see one by one. In Newton downhill, the advantage is it is independent of the initial solution, and it has a very high convergence rates when compared to the other conventional method, that is Newton traction method, that is NR method. But the disadvantage is here the convergence order is less than 2, so it fails the Jacobian matrix. If the Jacobian matrix fails means then the iteration does not converge, and we does not get the optimal solution. This is the main drawback in the Newton downhill. And second is the current injection method. Current injection means it has a very good convergence even in high loaded condition also, and it is very less sensitive to R by X ratio. This iteration, in iteration this R by X ratio plays a very important role, and but the drawback is it fails if the distribution generation number is high. And the third is hybrid superposition and Gauss-Seidel method. And hybrid superposition method, it does not need any Jacobian matrix. It is the main big advantages of the load flow method. But if the solar PV distribution generation is high means, then the Jacobian matrix fails to produce the fails to converge the solutions. And the fourth is improved hybrid superposition method. Improved means it is independent to the size of the Digi number, distribution generation. And the main drawback is it is very unsuccessful in the high load, that is heavy loaded conditions. Next, fifth technique is branch current or power based back forward method. Here this advantages it does not need any Jacobian matrix. It is independent to the size of the PV DG number, but it is very unsuccessful for the heavy loaded large size network. That is the main drawback in this feed forward and feed backward load flow methods. And next is the genetic algorithm based load flow method. The genetic algorithm based load flow method is that main merit is it is very simple to implement, and it is very reliable in convergence, and it is suitable for offline problems. But the drawback is excessive computational time for large size network, and it is very sensitive to the control parameters. And last is particle swarm optimization based load flow method. In particle swarm optimization, it is very reliable in convergence, and it is suitable for the offline problems also, and it is very faster when compared to the genetic algorithm. But the drawback is it is very slower in convergence than all other methods, that is the genetic algorithm, and it is not suitable for the large size network. And finally, it is artificial neural network load flow method. This artificial neural network has very least computational time, that is computation time is very less, and it is also suitable for both online and offline problems also. But the drawback is it is very limited to the specified input range. So these are the load flow methods which is used in the distribution side sectors. So next we see about what are the latest artificial intelligence techniques which is used in the power sectors. So this is the line scout. We are replacing this human workers for dangerous and it is highly specialized operations, such as it can lively maintenance of high voltage transmission line, and it has been a very long standing effort in the power community. This can be named as a line scout. So this line scout robot is it has been designed to reach 4 conductors of typical transmission line. One end of the arm is equipped with the point-able camera, and the other can hold a variety of variety of tasks, such as first is high quality visual inspection, and second is infrared inspection. Third is to check the condition of the splices, which can be measured by the electrical resistance. And fourth is tightening and loosening the bolted assemblies. And last is temporary repair the broken conductor standards. So these issues we can use this line scout robot. Next is a snake robot. This snake arm can perform a variety of inspection and maintenance tasks. So this snake arm is performing the maintenance in the nuclear power plant, which is implemented in the Sweden. Next, what are the challenges involved in this artificial intelligence in the power system? What are the challenges means normally the traditional conventional method is very complex, and their analysis and the control is primarily depend on the physical modeling and the numerical calculations. So with this development of the smart grid, with the high penetration of the environmental friendly renewable energy and microgrids, the transition of traditional power grid is applied to the smart grid system, which is export more uncertainties and the problem of the complex environment. Meanwhile, the current power system uses old infrastructure, which adds more uncertainties to the modern smart grid systems, because the communication network builds on the power system is very large volumes of the data with the high variability must be handled, and this is still a challenge of smart grids. Additionally, the researchers are still working on the robustness, adaptiveness and online processing of the artificial intelligence algorithms. Although there is a numerous data driving methods has also been proposed to deal with this problems of smart grids, but there is still several challenges are included. So let me see what are the challenges. First is integration of renewable energy. That is, it is highly integrated renewable energy is a key characteristics of smart grids. However, it presents several significant challenges due to variability and unpredictability of renewable energy, in which this power output can vary abruptly and frequently. So second is preserving the data security and privacy. This is a very important challenge. That is, it taking into account of employment of massive different devices and a two-way communication and smart grid system. It is more prone to the cyber attacks because it is directly exposed to the malicious users when compared to the traditional power systems. And many novel security techniques were developed to offer fast identifications of cyber risk, false data detection and system data theft, electrical theft and so on. So however, network protocols and operating systems and physical equipment in this current smart grid are still exposing the system to a wide variety of attacks. So the current AI solution is also have a trade-off between the security, privacy and the performance. Next, third challenge is a big data fast storage and analysis. Yes, that is another significant is how to continually improving the performance of storing and retrieving the big smart grid data in AI applications with robustly. And fourth is expandability of the AI algorithms. Generally, the AI algorithm have a black box problem, and they are not interpretable and explainable. And limitations in the AI algorithm means the development of AI technologies is greatly influences the deployment of AI to smart grid systems. However, every method limitations should be considered before applying them to the smart grid. So, future of AI in the power system is main objective is to achieve full self-learning system that will be very responsive and adaptive and self-healing and full automated and cost-effective. The conventional power system have some limitations in processing and analyzing the data that is now unknown with the smart grid. Thus, this AI technique, this artificial intelligence has been developed and applied to many applications in the smart grid system with the promising results. We can see many results which can use this artificial intelligence, which is very simple and effective. And artificial intelligence technique has been applied to several areas that is critical to the reliability and resilience of smart grids. Even there is some challenges is limiting the additional applications of AI techniques. And major among these challenges are the data privacy and security, as well as they can handle this black box in the AI. This AI techniques to achieve the human-centered approach to the AI solution designs. So finally, I concluded this artificial intelligence. The importance of the utilization of AI tool has been felt altogether in the areas of facility systems, and therefore we can need is highlighted and the easiness is evaluating the way of knows crisp concepts, and therefore the ability of these techniques to find out the technological improvement which is effect of soft computing techniques. The main feature of power grid design and planning is reliability, and conventional methods does not fulfill the probabilistic essence of the power system, and the results and this results is an increase in operating and maintenance cost, and finally tons of research is yet to be performed to preserve full advantages of this upcoming artificial intelligence technology for improving the efficiency of electricity market investments, and particularly power system which use the renewable resources for operations. So these are the finally I concluded my lecture series, that first we see what is artificial intelligence, and what is power system, what is the need for AI in this power system, and what are the artificial intelligence techniques we can use this in power systems. And there is various major families of artificial neural network, fuzzy expert systems, and what are the drawbacks and what are the advantages in the conventional methods, and why we go for this artificial intelligence in the smart grids, and what are the various challenges and future developments in the artificial intelligence in the power systems. So thank you, and these are the artificial intelligence